Now let's discuss Fermat's little theorem by way of an example. So the theorem says that if P is prime and A lies between 1 and P minus 1, then A to the P minus 1 is congruent to 1 mod P. So in this particular case here, P is equal to 7 and A lies in the range 1 to 6. And the claim is that A, for example 4 to the power 6 is equal to 1 modulo 7. 4 to the power 6 is equal to 1 modulo 7. Similarly, 5 to the power 6 is equal to 1 modulo 7. Now, we can just calculate in this particular case to find the answer. For example, if I take 2 to the 6, that's 64, and 7 nines are 63, which means the remainder is 1 after dividing by 7, so hence I get 1. So let's go for a systematic proof. So what we're looking at is, in say the case of 4, so we're looking at 4 to the power 6, and we're looking at the remainder after dividing by 7, and we claim that it's 1. Now, the trick is to look at what happens with the multiplication table. So here I have 4. 4 multiplied by 1 is equal to 4 mod 7, obviously. 4 multiplied by 2 is 8, which is 1 modulo 7. 4 multiplied by 3 is 12, which is 5 modulo 7. And so on. I get 415, 263, and we saw before that because we have a prime modulus, that this set of numbers is a permutation of this set of numbers. So here, now we make the observation that we have, since 4 times 1 is congruent to 4, 4 times 2 is congruent to 1, let's say 4 times 5 is congruent to 6, here. Now what happens if we multiply these numbers? So if I multiply 4 times 1 by 4 times 2 by 4 times 3, by 4 times 4, by 4 times 5, by 4 times 6. I have 6 4s, so that gives me 4 to the 6, and I have 6 factorial, and that is equal to 4 times 1 times 5 times 2 times 6 times 3, in other words, these numbers, which is a permutation of 1 up to 6, so the multiplication gives me 6 factorial. So multiplying all the elements on the left of the 6 congruent signs, I get 4 to the 6, 6 factorial. Multiplying all those on the right of the 6 congruent signs, I get 6 factorial. So it follows that 4 to the 6 times 6 factorial is congruent to 6 factorial mod 7, which means that 7 divides 4 to the 6 minus 1 times 6 factorial. 7 must divide the difference between that and that, which is equal to that. Now 7 is prime, and it's certainly not a factor of 6 factorial. So that means, because it divides this, it must in fact divide 4 to the 6 minus 1, which means that 4 to the 6 is congruent to 1 modulo 7. So we use the P as a prime, and we use the fact that 7 does not divide 6 factorial. This gives us the result.